morning everyone. Today we're starting with maths for term 2, which is all about number patterns. So today is the 20th of April. We are going to look at today's work, which is this, and that is all to do with number patterns and relationships. So number patterns you've done in grade 8 and 9, so today's grade 7 and 8, sorry guys, and we are basically just going to revise on that today, and yeah, good luck. So today, number patterns and relationships. Okay, for every pattern, write down the next two terms, the nth term and the 10th term. That is information that they usually ask for in any pattern. What I need to give you is a general equation that you should remember and use. So Tn is equal to An plus C, where A is the constant difference, as well as An is A plus N minus 1 D, where A is the first term, N is the position of the term, and D is the constant difference. What do you use this for? You use this to determine the formula of any pattern. So depending on what the number is or the pattern looks like, that is going to determine how you are going to do it. Then let's look at the first pattern. Question number 1, our pattern is 3, 6, and 9. So the first step that I would like to show you is to determine step 1, how to set up a table. So we take the information that they have. They've given us the value of 3 terms. They've asked us for 2 additional pattern terms. They've asked us to determine Tn, and they've asked us for term 10. Therefore, this is the table that we're going to need. Our next step is to take the information that we have and put it in the table. So what do we have? We have the value of term 1, which is 3. The value of term 2 was 6. The value of 3 was 9. If we follow this pattern, we see it's 3, 6, 9, 12, 15, and we don't know what an n is. How can we determine it? We complete the next 2 terms. We've done that. So that would be 3, 6, 9, 12, and 15. Then we move on to determine the constant difference, which is A, between the values, if there is a constant difference. So we are going to look at our pattern, which starts at our first value, which is 3. What did we add to 3 to get to 6? We added 3. What did we add to 6 to get to 9? We added another 3. 9 to 12 and add another 3. So our value for A would therefore be 3 plus 3. That's important to remember that A is a positive, because later you will see that A can also be a negative. Okay, step 5, work out the formula for this pattern using the method and the table that follows. So I've already put in the information that we're going to need. Term number 1, An plus C. That is the general formula. We have just determined that A has a value of 3. Therefore, we take this formula and we place these values in them. So we need to get to 3. 3 times 1 is 3. For term 2, 3 times 2 is 6. 3 times 3 is 9. Now hang on, we have to add a C. But what do we need to add to 3 to get to 3? We can't add anything, therefore we add a 0. And for 6, also a 0. 9 is also a 0. Therefore, we can definitely with certainty say that C has a value of 0. Therefore, our final formula for n is just 3n. And the value for C is 0, therefore we can just leave it out. We don't have to put it into our final formula for n, we can just say it is 3n. And if we determine that for the 10th pattern, then we put in 3 times 10 is 30. So the 10th pattern in this certain relationship, the answer would have been 30. Okay. Now, in number patterns and relationships, we are fortunate enough not to have just one type of number pattern, but there are 4 types of number patterns. When we look at each one of them in isolation, they look like nothing, but you need to know the difference when you have to apply the information to specific patterns. Okay, so in this situation, we have arithmetic patterns. These are patterns that always have a constant added to it. The constant, which is A, can be a +2 or a -2. That is the constant that we work with every time. We can see here that we add 6 and then we add a negative. So that is what I explained to you earlier, where a C can be a positive or a negative. And this also applies to A. A can also be a positive or a negative. Okay. Then we get geometrical patterns. This is a pattern where we multiply with a constant, not add it. So in the previous example, we went from 7 to 9, from 9 to 11. So every time we added a 2. Here it was 3 to 7, 7 to 11. So every time we added a 4. But if we look at the geometrical patterns, we can't add a constant to get to the next term. In this first set, we have to add 18, and in the next one we add 180. So that doesn't really make sense. Therefore, if we multiply, then you see 2 times 10 is 20, and 20 times 10 is 200. Therefore, we multiply with a constant, and that is how we get to this formula. Then we have geometrical patterns. These are the ones that you need to know off by heart. It's the ones that you can see that the term value increases exponentially each time. We start with 2, then we go to 4, and 4 to 8, and every time we can see we are multiplying with 2 times 2 is 4, 4 times 2 is 8. Great stuff. But that does not necessarily mean it's going to apply to the next ones. In this case, this specific pattern can be identified as an exponential pattern as well as a geometrical pattern because we are multiplying with 2. But in other examples, it's not going to be like that. 3 would be different, for example. So 1 to the power of 3, 2 to the power of 3, 3 to the power of 3, you won't be able to multiply there. So for this example, you've got 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. If you see that the pattern increases exponentially each time, that means increases by a lot and not a constant, try writing your numbers, the term values, as the product of its prime numbers. That is going to give you a little bit extra information that you might be able to use to determine the patterns formula. And then the last example is a Fibonacci pattern. This again is a very special pattern, just like squared numbers and cube numbers. And this is one that you will need to learn out of the top of your head. It is not one that comes naturally, and it is quite a difficult one. However, it always remains the same. So Fibonacci's pattern starts with being the sum of the previous 2 terms. So 1 is just 1. This 2 would be 1 plus 1 is 2. 1 plus 2 is 3. The important thing to remember and how to identify Fibonacci pattern is that term 1 is a 1. Okay, and they always have to give you 4 term values. If they don't give you 4 term values, it is impossible to determine whether or not it is the Fibonacci pattern or not. Okay, let's try another pattern by ourselves. Okay, Here they start by giving you x and y. Why would they start to give you x and y instead of term values? The reason for that is the next section of work that follows on number patterns and relationships is starting to draw graphs. And in graphs, you've got your x-axis and your y-axis, and therefore they are able to give you patterns that look like this. Okay, let's look at the information that we have already so that we can move on. Okay, what have they given us? They've given us 3, 12, 27 and 48. Okay, let's take that information and place it in the table in which we can work out. Okay, so I've already placed in the information we've got. We've got 1, 2, 3 and 4. 1, 2, 3 and 4. Let's determine our constant difference now. Is there a constant difference? From 3 to 12 we add 9. From 12 to 27 we add 15. From 27 to 48 we add 21. Therefore we don't have a constant difference. So our first formula that I've given to you here right at the top, let's just quickly go to it. Any moment now. Come on. Okay, right here at the beginning of the lesson, I gave you these two formulas, that one and this one. If you look at the two patterns, you will see that in this case, we're not going to have a constant difference that we can add. Therefore, we are not able to use this first formula. We can try and use the second formula, and that is how we're going to do this one. Okay. So take the information that you have already, 1, 2, 3, and 4. We have to multiply with something, okay? We don't know what it is yet. So let's take our answers that we have so far, the 3, the 6, the 9, and the 12, because we can see that 1 times 3 is 3, and 2 times 6 is 12. 3 times 9 is 27. So yes, there's not a relationship between the y's, but there is a relationship between the x and the y. So if we take the 3, we can say 3 is equal to 1 times 3. So this is where we write it as the product of its prime numbers. So it doesn't necessarily have to be prime numbers. Let's just see what happens. Okay, so 6 would be equal to 2 times 3. And the next one is 9, and we can say that is 3 times 3. By just looking at these first three terms, we can see that every time we multiply it by 3. So when we do 12, we can say, hang on, but we can say 4 times 3 is 12. And if we now analyze what we've done already, we can see here at the beginning, we have 1, 2, 3, and 4. Okay, these 1, 2, 3, and 4 every time refers to the pattern number. And hang on, here we also have a 1 and a 2 and a 3 and a 4. So again, we multiply with the pattern number. And then the last thing we multiply with in this specific pattern is a 3, which is a constant throughout every single one. Therefore, we can assume that we take our pattern number, we multiply it by our pattern number, and then we finally multiply it by 3. Therefore, our general formula is n squared plus 3. Okay, make this n right. N, and then our 2 would be an exponent. So our general formula looks like this, n squared plus 3. So we take this information and we can apply it to 6. So 6 times 6 times 3 would give us 108. Therefore, our 6 value of this pattern is 108. Now they do something strange. They give us our answer and we have to go backwards. So we take 300 and we divide it by 100. Divide by 100. That will give us 3. Oh, what am I doing? Divide by 3 to give us 100. And then we take 100 and we have to get the root of 100. And we know that 10 times 10 is 100. Therefore, our n in this pattern is equal to 10. Okay, excuse the capital letter. You guys at least know what it should be. Okay. And that is basically how we get to this pattern. Okay, if you need any other help with this work for today, please just let me know and I'll help out where I can. That basically sums up patterns and number relationships for today. Have a great day.